point in the middle of the circle is actually really important because a circle is the set of all points that are equidistant from a given point called the center of a circle. So realistically, one of our most important things is that point in the center. Although we always talk about like we could see a circle, we could do that. One of the most important things is that point inside. So when we name a circle, we actually name that point that's inside. That is the name of our circle. So if I look down here, it says a circle with center P is called circle P and can be written like circle P. So if I told you to draw circle P and I didn't give you any explanation of what you're supposed to do, you would just draw a circle. You'd put a point in the center of it, and you'd put a P by that point. So that point is important to us. That point right there is important to us because that's a center circle, and every other point is equidistant from that. Now, are you going to have to recite that definition to me? No. But you should know if I say circle P that I'm talking about that center point that names the entire circle. Okay. Let's talk about the very first word that you might have never heard of. Well, maybe you played guitar. You heard of something called a chord. Chord's a little bit different when you talk about a circle. A chord is a segment with endpoints on the circle. It has to have exactly two endpoints. So think about it like a straight line. If I draw a straight line anywhere on the circle, I could hit 2 points at any. Like just picture, if I draw a straight line here, it hits 2 points, 2 points, 2 points, 2 points. When we talk about the chord, we're not talking about the whole line I can draw. It is just from one point to another. So a quick example of a chord, we can draw a line anywhere in the circle, and that is a chord. You could draw it anywhere on that circle as long as it hits in 2 places. We're going to talk about something in a second that only hits 1 place, but a chord, those 2 things. Now, I don't want to use the term line. What's another term for something that starts and ends? Instead of calling it a line, what's another word for something that starts and ends? I got those 2 things. A segment. It really is a line segment. It's a line segment. That's why we use the term segment. All right, a radius. Got a cool plural. Radii. Is a segment with the endpoint at the center of the circle and on the circle. So a radius is something that goes to the center of the circle and stops. So maybe an example of that would be this. That right there is a radius. Now the way I think of a diameter and I think about its length is a diameter is kind of 2 radii stacked together. Because a diameter is a chord, so it has to touch both sides of the circle, but it happens to pass through the center of a circle. So an example of that might be, so we draw a chord. It's a very specific chord that goes to the center of the circle. That right there is called a diameter. Maybe I should try to put into the middle of it. That is a diameter. But a diameter is unique. If you think about this way on a diameter actually has 2 radii. So if I give you a diameter, I could say, oh, you definitely have at least 1 radius because we have a radius here and we have a radius here. You also have a chord. So a diameter consists of all 3 shapes that we just talked about. A diameter is a chord. It consists of 2 radii and it's itself a chord that goes through the center. So really, if you know a diameter, you should know those other 2 terms. Okay, so quick example here. So we have this drawing. How would I name that drawing? Circle C. I would call it circle C. It is whatever that point is in the middle. This would be called circle C. Remember, you can use slight notation on this. So we could put a little arrow here and go, Mr. Pabian, I'm talking about circle C. Or you can just write circle C. You don't have to memorize that. The only time you have to know that is when I force you to use it. If I have like a test question that says, look at this shape and C, but normally you can just write circle C. Doesn't take that long to write circle. If you forget that term, we just go circle C. All right, chords. Chords are segments. Can someone name a segment down there that's a chord? Yeah. AB, yeah. So one chord would be AB. Now it's a segment, so I'm going to put a segment on top of it. I'm not going to put the full line symbol. I'm going to put the little segment symbol. Does anyone see another chord that's on there? Yeah. DE. You're going to say DE? I would agree. Does DE start and stop on that circle? Yes. It has 2 points that are on the circle. I have point D and point E. Those are on the circles. Are there any other chords on there? Anyone see any other chords? I don't either. Okay, let's move on. Does anyone see a radius? Oh, who did? Zavar. CF. I would absolutely agree with that. So a radius could be CF. Oh, I put CE, but I wanted CF. Yeah. DC. You're going to go with DC. And? EC. You're going to go with EC. Could I flip the letters on any of those? Yeah. Could you call it FC? CD? C? Yeah. All right. Anyone else see any other radii? Nope, that looks about it. Are there any diameters on there? Does anyone see any diameters? Someone new? Joseph? DE? But didn't we say DE is a chord? Is it okay that DE is a chord and a diameter? Oh, because the definition of diameter is it starts off being a chord. It's a very specific chord because it goes to the center, but at its heart, it's a chord. So it should be in both places. Yeah?
Isn't it just every line because the diameter consists of all three things or not?
Would it be, say that again, one more time.
Like every single point like you get because it doesn't have diameter consist of all
Yeah, so if we say DE's a diameter, it should break down into 2 radii. And if we look here that we have a DC and an EC, and it should be a chord. So you should see these letters appear in all 3 things. So as soon as, like you said, if you have a diameter, you should be able to just break it apart into a bunch of other things. All right, that in short is a circle. And those are the big terms that we need to talk about. We'll talk about a couple other things, but those are the big terms we're going to be using. Don't get lulled into circles. Circles we'll get to some complex things. I don't think tomorrow, but we'll get to ones where we have like right angles and different rules. It's going to be a lot of kind of rule following. There's not a ton of them, but they're just specific enough that we can create right triangles in there. And what does right triangles typically lead to? What do right triangles typically lead to? Pythagorean theorem. And one other thing we did with, we haven't done it in a while. It rhymes with hoa, SOHCAHTOA, trigonometry. So we're going to start throwing those in. Even though it's a circle, we'll still have right triangles. That's why we had to build everything up to here. All right, I will note, and this is what I kind of talked about before. A radius is half your diameter length, or a diameter are 2 radii put together. When we start talking about lengths, that's going to be important to us. All right, let's bring up 2 words, 2 important words, tangents and secants. A tangent is a line that just grazes the circle. It just hits the circle in one point. That point is called a point of tangency. So if we look here, we have a point of tangency right here at A. So a line that intersects the circle in exactly one point is a tangent line. So it never enters the inside of the circle. It just grazes it, hits it one place, and that's it. Then we have a tangent line. Some ways we could describe this is we could say something like line AB is tangent to circle. What would I name this one? C. Why do I call it C? Did I just make that up? It's the center. It's that middle point. It is circle C. Now, I will point out, we'll say things are tangent even if it's not a full line. A segment can be tangent to a circle. A ray could be tangent to a circle. Could someone refresh my memory? What's a ray? I just say things and then I forget what they mean. Joseph?
Has a dot and an arrow in there.
As a dot and an arrow, it just goes one direction for all the time, and it's kind of a combination between a segment and a line. But all of those can be tangent to a circle as long as they hit in one place. It becomes... What was that? You could think of it as part of a line that could exist, because I could put that arrow on the other side. All right, so all those different shapes can be tangent to a circle as long as it just hits it once. Now, we already talked about a chord. We said a chord was a segment. I really focused on the fact that it's a segment because it starts and ends on that circle. If that chord extends further, we call it a secant. A secant is a line that intersects the circle in 2 points. Now let's note, a secant does create a chord. Because if I look here, I have this secant line AB, but it also consists of this chord right here. So if I just talk about the red part, that's a chord. So I could talk about 2 things on here. I could say you have chord AB, and I'll know what you're talking about. If you tell me chord AB, I know it starts and ends on that circle. If you tell me look at secant, the line secant to that circle, how did I put that? Yeah. I could say something like AB is secant to circle. That'd also be C. So that time I just used the word circle. You can do that, it's fine. All right, so when I talk about secants, we're talking about something that goes past the circles. When I talk about a chord, it starts and ends within that circle. It has to be a segment. That's why I'm really crucial that we note that a chord is a segment. When we talk about the secant, that has to be the line that goes through it. Questions on tangents or secants? Or chords or diameters? Or radius? Okay. This stuff isn't super important. Just keep it in mind. As with figures, pairs of circles can be congruent, similar, or share other special relationships. 2 circles are congruent if and only if they have congruent radii or congruent diameter. They're the same size. So if I need to prove that a circle is congruent to another one, I just need to show that their radius or their diameters are in fact congruent. All circles are similar. And if you think about what similar is kind of like if you take a magnifying glass to an object, bigger, smaller. You could take any circle and take a magnifying glass and make it bigger or smaller. It's just a circle. They're all the same shape. Think about it like a triangle, how many different ways there are to order a triangle. We have obtuse triangles, acute triangles, right triangles. A circle is just a circle. There's no right circles. There's no obtuse circles. It's just a point that's equidistant. All the points are equidistant to a center point. Then the last term I want to bring up is concentric circles. Concentric circles are coplanar circles that have the same center. So we kind of have circle A there, but there's 2 circle A's. We have kind of a small circle A, and we have a big circle A. There's no great way to describe which one you're talking about. So if I wanted to talk about the small one, I would say circle A with radius AB. Because the name only has 1 letter. And these both have the same center. All right, let's get to some really important stuff. This stuff is going to reverberate the rest of this kind of section. So understand what I'm about to tell you. There are 2 very important angles that we need to talk about. A central angle and an inscribed angle. I like the term central angle because it connects at the center of your circle. A central angle is an angle with the vertex in the center of the circle. This right here is a central angle. You need to know that term, and you need to know what I'm about to tell you next. And we'll actually have a full lesson about this. But let's say someone tells me the measure of this angle. They tell me that's some kind of degrees. It's 40 degrees. They tell me the central angle is 40 degrees. The important thing about knowing that's 40 degrees is I'll also know that this section I'm doing right here is also 40 degrees or x degrees. These will be the same degree measure. How many degrees would be in a full circle? 360 degrees. So whether I do 360 in here or 360 out here, it's the same. So if I ask for the degree measure of this, you're going to say it's the exact same thing as the central angle. I'll also note that the central angle is actually made up of, if I put a point right here, what is this shape? That goes to the center of the circle and to the outside of a circle. Oh, it is a ray. I agree. I'm trying to just focus on what I just highlighted there. Let me make something disappear real quick. What would be another name for that segment right there? It would be called a radius. So a central angle always has 2 radii. So that's a radius. This is also a radius. Important to note, because if I give you this length, I actually gave you this length as well. One of the hardest things in a circle is to realize that all of the radii are the same. I know you guys are just looking at me like, oh, it's going to be super easy. I'm telling you right now, realizing that radii are all the same, because there's going to be really complex drawing, is going to be one of the most complex things you need to do. So start getting in your head, if I know a radius, I can mark every one of them that I see. All right, the next one we're going to talk about is an inscribed angle. An inscribed angle is an angle that has a vertex on a circle and the sides that contain chords. So if I put 2 chords together, so if I look at this line right here, this is definitely a chord. That right there is a chord. The other side is also a chord. So an inscribed angle kind of goes to the back of the circle. It goes all the way through. Now, the important thing about an inscribed angle is, let's say someone tells me I know the angle of that arc, or that angle. So I have that measure of that angle. That's 40. When it was a central angle, it was the exact same size. If I said my central angle is 40, that arc it cuts is also 40 degrees. When we have an inscribed angle, the arc it cuts is actually going to be twice the measure of the angle, so that would be 2x. Like I said, I think this is such an important thing that this isn't actually part of this lesson. We'll have an entire lesson just kind of for this fact, but it's good to get this in our head already. Inscribed angles, we think of double. We double it, and we got that angle. All right, arcs. Arcs are what I kind of shaded in here. That kind of degree measure or whatever. I want to focus on chunks of the circle. Those are called arcs. It's a portion of the circle defined by 2 endpoints. So we don't have to talk about a central or an inscribed angle. A minor arc is the shortest arc connecting 2 endpoints of a circle. So let's do an example here. This right here would be a minor arc. I think a good way to think of a minor arc is it has to be less than 180 degrees. So it's less than half. It's the shortest distance from A to B. So this needs to be less than half the circle. It's our short arcs. So the shortest arc connecting 2 endpoints of the circle. To tell someone it's a minor arc, you use 2 letters. A minor arc, you use 2 letters. So this is how I'm going to tell someone I have a minor arc. I'm going to put an arc up there, and I'm going to put AB underneath. This tells me I'm talking about an arc. 2 letters means minor arc. That means minor arc. So if you tell me arc AB, I know I'm looking at this, either a measure or a degree. Now, a major arc is going to be the longest way, basically, to get to those 2 points, because there's 2 ways I can see to get from A to B. I can see the short way, which is our minor arc, and I see a long way, which is going, start at A, go the long way, and get to B. So for my major arc, I'm going, let's go this way. I want to talk about this chunk of the circle. So if I'm going to tell someone to go the long way, I want to go the long way. I want to know the distance if I walk the long way. We're still going to use the arc symbol. Shortest direction, 2 letters. I want to guess how I go the long direction. I need to use 3 letters. So 2 letters means I'm going the short distance. 3 letters means, hey, make sure you go A to B, but make sure you go the route that includes C. So we're going to go arc A, B, C. That is going to be 3 letters. Bless you. 3 letters means major. It means go that long way.
Do you include that?
Yeah.
You do ACB?
You could do AC. Oh, yes. Oh, good catch. Would ABC be correct? Let's think about this. Let's put our thinking caps on.
That includes AB.
If I said ABC, do you think I highlighted the right part of the circle? Just use your thinking. If I say go from A to B to C, did I highlight the correct part of the circle? No. What would be correct? Can you say that again for the class? It should have been ACB. I just was not zoomed in the right way. I was just testing you, really. ACB would have to be the correct way, because just putting our thinking caps on, if I said ABC, can you picture the arc that I would create with ABC? Can we see it? Can we see ABC at least? It would cover B. So let's color that in red real quick. So if I said ABC, you should have found this. Okay, but I wanted ACB because that was the first one I colored in. Questions on minor or major arcs? Minor, 2 letters. Major, 4 letters? 3 letters. Ooh, already forgot. All right, let's talk about something that falls in the middle. It's called a semicircle. How many degrees are in a circle? 360. How many would be in half a circle, you think? 180. How many degrees are in a straight line? 180. So there's a lot of actually 180s in a semicircle, because I can picture, okay, it creates a straight line, which is 180 degrees. I also know that, if I go all the way around here, it'd be 180 degrees. What was that? Oh, okay. So we have 180 degrees in a semicircle. Whether it's inside or outside, we look at that. Now, if I want to describe a semicircle, we have to do it the same way we do a major arc. I need 3 letters, because I need to know if I'm going to go to the top of the circle or if I'm going to go the bottom of the circle. So if I was naming this semicircle, I should have had 3 letters. I need a letter. A. Another letter? B. Oh, creative this morning. 3rd letter? F. Okay, there we go. So if I want to say this semicircle, I actually call it like a major arc. I'm going to go arc A, B, F. You might want to get that written down. That's important. So if I ask for a semicircle, I want 3 letters just like it's a major arc. Because I want to know, are you talking about the top half of the circle or the bottom half? We all know I'm talking about 180 degrees, but I need to know which half of the circle you're talking about. That's why we use 3 letters. All right, intercepted arc. We already talked about this a little bit. Intercepted arc is the arc created by an angle. So if I cut an angle through here, my intercepted arc would be right here. Now, take a second to look at that drawing. Just take a second. Look at that drawing. Can we all look at the board? Don't look at your notes. Don't look at your notes. Look at the board. Look at the board. Look at the board. Don't look at your notes. Don't look at your notes. What kind of angle is this? Central or inscribed? It's inscribed. If I told you this was 20 degrees, what would the intercepted arc be?
40.
It would be 40. What if the intercepted arc was 100? What would the angle be?
50.
It'd be 50. If this was a central angle, so if I drew a central angle here, and that central angle is 50 degrees, what would the intercepted arc be?
50.
It'd be 50. Now, do you see how these can interconnect? I could tell you that this is 50, which would make this 50, which would make our inscribed angle what? 25. So if I give you this, you can go out and you can come back in. Once again, this is a future lesson, but it's really, really important. It's really important that we start being able to pick these out. Those are big questions that show up a lot. All right, questions on anything we just covered? Hey guys, let's do the first homework problem together. How's that sound? I just want to make sure we're on the same page. I'm going to read it with you. So if we look through 1 through 7, we're supposed to draw a picture based upon the descriptions. It says that I need to first start out with circle A. The nice thing is every one of these tells you to start with a circle. So let's start with a circle. I'm going to freehand mine. We'll see how well I do. Ah, it's a beautiful freehand. Just freehanded that. You guys saw me do the whole, yep, that was freehanded. And then it says circle C, so that means that we need to put a point. Did it say circle? Circle A, sorry. So we need circle A, so we need a point there that has an A in there. Okay, I need to have two things. I need to have chord BC and tangent CE. Now, here's the reason why we're doing this together. I don't care where you draw your chord. Your answers aren't necessarily going to look exactly like mine. There's multiple different ways to do this. For example, I want chord BC. You might have did chord BC goes here and here. You might have done chord BC is a diameter. Usually don't make it a diameter because I'll tell you if I want it to be a diameter, but I can't technically take points off. But remember with rectangles and stuff, I give you the most descriptive thing I can. So usually if I want a chord, I want something that just looks something like that or that. Or if you want to split hairs, you could do something like that. Don't do that. Make it obvious that we have a chord. So I'm going to go ahead and I'll make a chord. Don't erase your chord if you have one. Just make sure you have 2 points on it. I need to see those 2 points because I need to label those BC. Then they tell us that we need to have a tangent line CE. Now, here's why I want to show you guys what I'm expecting of you. This is where we lose points if you're just like, oh, I'll just draw a tangent down here. What 2 letters need to be included in that tangent line?
C.
I need to include the letter C. Didn't I already make a C? I can't make another one. We can't go ahead and go, well, I'm going to create another C down here. If you created a point, that stays there. So this tangent line has to go through that point C that I already created. So we need something that looks like that. All right, so now I have a tangent line. I need to call that tangent line EC. That means I need to put an E on. I don't care where you put E. We could put E down here. Cool, that's line EC. I could put the E up here. Cool, I now have EC. You could put E wherever you want on that line and you have line EC. And is EC tangent to circle A? Can someone raise your hand and tell me how I know that's tangent? Yeah. It made a radius? Not a radius, because I guess kind of. We could have a radius here. I'm looking for something else that describes a tangent line, though. I could see where you could see a radius if I drew it in there, but a tangent has nothing to do with a radius, honestly. What makes something a tangent line? Yes?
Outside the circle.
1 point is outside the circle. You mean this point right here? Like this one? Yeah, we have 1 point outside, but the more important point is that it intersects in 1 point. I think we're saying the same thing. It has to hit the circle in 1 point. That's the more important thing to say, is that it hits the circle in 1 point. Because think about your description. Your description is there's 1 point that's outside the circle. Well, I could draw a line, and I definitely have points that are outside the circle, but it never intersects. So the important thing is that it intersects the circle in 1 point. That's what makes it tangent. Questions on what I just did? All right, guys, you have a lot of time. We got a lot of time to work through these. Ask questions if you get stuck. The answer key is online, but I highly suggest don't change your drawing because my answer key has it differently. I just may have pictured it differently. Just raise your hand and say, does this match the description that's given to me? So your drawing should not match my answer key exact, otherwise you're just copying my answer key. That's basically what we're going to see. Yes? Yes?